Good day and welcome to Wise Academy. If this is the first time you have seen our video, kindly click on the subscribe button to follow us, the like button on this video if this video is helpful to you, and leave a comment for us. If you have any difficult question, you can drop it in the comment section and we'll attend to it and we'll tag you in our next video. Alright, so we're still dealing on operation of set using Venn diagram. So we're going to be drawing the Venn diagram of the universal set that has element 1, 2, 3, 4, 5, 6, 7, 8, 9, and 15. Now, this universal set has a subset A, B, and C. So we're going to draw this subset and we're going to draw this subset and we're going to look for the number of elements in A union B union C. So let's represent this element on the Venn diagram. So you know your universal set. Let's do our universal set first. Okay. Let's increase this a little. So these are our universal sets. So about that, please just follow us. This is too small, that's why I'm erasing it. Alright, so we're going to draw the universal set. Please make sure when you are drawing your own, it's straight. It's because I'm using the on-screen marker board, that's why it's coming out this way. So the elements in A are 2, 4, 6, 8. And the element in B are 1, 4, 9. The element in C are 4, 6, 8, 9, and 15. Please ensure you solve alongside us so that you don't have any difficulty. Remember, the best way to understand anything is by practice. So when you solve alongside us, you are practicing. Alright, so let's observe our subset very well. You see we have 2. 2 is only in the subset A, but we have 4 in the subset A, B, and C. So which means A, B, and C, they all intersect each other. So we're going to draw the subset now. So I'm going to call this A, this B, and this is subset C. So let's take this carefully. So for our set A, our subset A, we have 2. 2 is only in subset A, so I'm going to put 2 here. We have 4, which is in subset A, B, and C. So this is where A, B, and C intersect. So 4 will be here. So we have 6. 6 is in subset A and in subset C. So you are going to look for where A and C intersect. So this is subset C and this is subset A. So this is where they intersect here. So we're going to put C here. So we're going to go for 8. 8 is in subset A and also in subset C. So this is 6 and 8. So go back to subset B, we have 1. So if you observe the subset B and C now, you see that 1 is only in subset B. So we're going to put 1 here, meaning it's only subset B. Your 4, which is in ABC, is already here in ABC. Then your 9 is in subset B and also in subset C. So we are going to put 9 in the set where the subset B and C intersect. So your 9 will be here. Now go back to subset C. We have 4, which is in ABC. We have your 6. You have your 8, which we have discovered there. We have your 9. Also 15. 15 is only in the subset C. So this will be 15. So if you draw your subset and you have it this way, congratulations, you have already drawn your Venn diagram. So this is your universal set. This is your universal set. So let me write out all the elements of this universal set. So the element of this universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 15. Alright, so let's check if we have all the elements in this universal set now. So this is 1. You have your 1 here. This is 2. You have 2 here. This is 3. So there's no 3 here. So 3 does not belong to any subset, but it's also part of the universal set. So I'm going to put 3 here. You have your 4. It's already there. Your 5 is not there. So your 5 will be here. So you have your 6. Yes, 6 is already in the subset. 7 is in no subset, so I'm going to put 7 here. So 8, yes, 8 is in the subset. You have your 9 also in the subset, and your 15. So with this, all the elements of this universal set are in the Venn diagram. Alright, so but we're not going to end there. Remember, we were told to look for the number of elements in A, union B, and C. So which means, if you know what union of a set means, union of a set means all the elements in the subset now, A, B, and C. So all the elements in this subset now is, you have 1 here, you have 2, you have 4, you have 6, you have 8, you have 9 and 15. So let's count it together. This is 1, 2, 3, 4, 5, 6, 7. So all the elements in A, union B, union C is equal to 7. Alright, so since we have this now, let's work with our formula. Let's work with our formula to see if we are correct. Let's check if we are correct by working with our formula. Now, you have been told when looking for the union of a set, we have a formula for it. So this is your N, your A, union B, union C. Will give you, so you consider the number of elements in each of the subsets first. So number of elements in subset A plus number of elements in subset B plus number of elements in subset C minus, or you subtract your number of elements in A intersect B, that is where A and B intersect. Also, you subtract the number of elements in A intercept C, where A and C intersect. Then you go over to B, and you are going to subtract the number of elements where B intersect C. So with this, you think you are done, right? No, but you are not done. You are going to add also the number of elements in the subset where A, B, and C intersect. So this will be A intersect B intercept C. So this is your formula. So we're going to look for the number of elements in A, B, C. Then we're going to look for A intersect B, A intersect C, and B intersect C. So work with me. So these are subsets. So the number of elements in this subset here is how many? So count with me. This is 1, 2, 3, 4. So the number of elements in the subset A is 4. Number of elements in subset B is 1, 2, 3. Number of elements in subset C is 1, 2, 3, 4, 5. So it's 5. So we're going to look for A intersecting B, number of elements there. So A intersect B. So which means you are looking for the elements that are both in A and B. So the number of elements here will be, look at your A and look at your B. You have 4. Yes, you have only 4. You have only 4. So the number of elements here is 1. Number of elements there is 1. So number of elements when A intersects C now. So A intersects C, our number of elements is going to be, so go back to this, look at the subset A, look at the subset C, where A and C intersect. You see we are having 6, and we are having 8, and we are having 4. So that is 3. Or you can also come over to your Venn diagram. You look for A intersects C. So this is A, this is C. So at the point of intersection, you see we are having 6, 8, and you see that we are having 4. So this is 1, 2, 3. So that's what we have here now as 3. So we're also going to look for B intersects C, the number of elements when B intersects C. So this is B. You have 1, 4, 9. So we have 4 and 9. 4 and 9 in both B and C. So this is 2. Then we're going to go over to where A, B, and C intersect. So this is A intersect B, intersect C. Where they intersect now? Okay, so which means I look for elements that are in both A, B, and C. So we have 4. We have 4 here. We have 4 here. We have 4 here. So that's the only element. So the number of elements when A intersects B and intersects C is equals to 1. Alright, so let's check this in our Venn diagram. Let's see the point where A intersect B and center intersect C. So you can see where C and A and B meet is at this point here. It's at the point where the 4 is. So I just make it a little bit thicker so you can spot it from your hand. So you can see that the only thing that is there is 4. The only element there is 4. So with this, you have all your parameters. So now let's go over and input into this our formula. This is A union B union C, which is to look for all the elements in the subset A, B, and C together. So let's write it out now. So when the number of elements in set A, you have gotten it as 4. The number of elements in set B, you got it as 3. So we're going to add 3 to this. Number of elements in the set C, we got it as 5 when we calculated and checked for it. So this is number of elements when A intersects B. So look at it here, we got it as 1. So this is subtract 1. So number of elements when A intercepts C, we got it here as 3. We got it as 3. So number of elements when B intercepts C, we got it as 2. Then we add this number of elements when A intersect B and theta intersect C. So this is it. We got it as 1. So let's add it together now. So we're having 4, 3 plus 5 plus 1 minus 1 minus 3 minus 2. So this becomes 4 plus 3, which is 7. Add 1 to it, 8 plus 5, so this is 13. Subtract minus 1 minus 3 minus 2 is minus 6. So we have this as 7. So you can see that your formula gave you 7, which is the same value we got when we observe it from our Venn diagram. So please, if this video has been helpful to you, click on that subscribe button to follow us. Click on the like button and drop your comments. Thank you very much.